Okay, refractions of sound. Refractions of sound wave. For refractions of sound wave, you need to know the two experiments. Okay, so we do these experiments. We have these speakers here, and then this audio signal generator, and it will produce a sound wave. And then we have this microphone here to detect the sound wave connected to the cathode ray oscilloscopes. Okay, it shows the waveforms of the wave produced. And then in between the speakers and this microphone, we put the balloons. And take note that the balloons of the shape of the balloons is like the convex lens. It's like the convex lens. Okay, convex lens. And then the first experiments, we fill the balloon with carbon dioxide gas. Okay, and then the result, we found that with the balloons, the amplitudes of the sound increases compared to without balloons. If there's no balloons, this is a result. If with the presence of the balloons filled with carbon dioxide gas, the amplitude increase. It looks very weird because the balloon, suppose a balloon has blocked the sound wave. But after that, we found that the amplitude of the wave become higher. Means that the sound become louder. Okay, so the amplitude of the sound increases. So this can be explained by the refractions of light. Refractions of the light. Okay, explanations. That is because carbon dioxide is denser than the air. Okay, it's denser than the air. So when the wave move into this carbon dioxide gas, the speed change. Actually, when it move into the carbon dioxide gas, it move faster. Okay, so the sound wave is refracted approaching the normal when the wave propagates the air into the balloon, away from the normal when moving out from the balloons. Okay, so move into the balloons, it move approaching the normal, come out, it move away from the normal, and as a result, the sound wave is converged. The sound wave is converged. If the sound wave is converged to a smaller area, so the amplitudes will become higher. So the microphone detect a higher amplitude of the sound. The second experiment, now this time we fill it with helium gas, and then we found that the result is different. With the balloons, the amplitude become lower. Just now carbon dioxide with the balloons, the amplitude is higher, right? Okay, and this one, if we fill the balloon with helium gas, then the amplitude become lower. That is because helium is less dense compared to the air. And when it's less dense compared to the air, when it go into the balloon, it will be refracted away from the normal. And when it come out from the balloons, it will be closer to the normal. Okay, and as a result, the wave is diverged to a wider area. And when it's diverged to the wider area, the energies of the wave will reduce. Okay, because it's shared by the wider area, and as a result, the amplitude will decrease. And the last thing is the phenomena of sound wave. Sound of a distant train is louder at night. If you stay near to these railways, okay, you will find that at daytimes, okay, the sound from the train is not so loud, but at night it's very loud. Why? Okay, the explanations. Okay, the speed of the sound is affected by the temperature. Okay, speed of the sound is affected by the temperature. If the air is cool, the speed of the sound will be lower. It will move slower. Okay, but if the air is hot, then the sound will move faster. So sound move faster in a high temperature air and move slower in a low temperature air. Okay, and at night the ground is cool. Okay, but the air can be still warmed due to the different specific heat capacity. Okay, and as a result, at the warm air, the wave move faster. The wave move faster, and here the wave move slower. and this causes the sound wave refracted. Okay, and if the wave is refracted, then it will converge. Okay, it's converge. If you stay here, then you will hear a louder sound at night. At daytime, the wave is spread. The wave will be spread to a wider area. Okay, it's spread to a wider area. So therefore, the amplitude of the sound wave reached here is very low. Okay, so the sound is not so loud. But at night, due to the refractions of the sound wave, okay, the wave is converged here, and therefore you can hear a very loud sound. Let's see the explanations. Okay, so at night, the air closer to the ground is cooler than the air further from the ground. The sound wave travels slower in cool air, and as a result, the sound wave is refracted. Okay, so therefore it converges to the observers.